Hello everyone, and welcome to another News Coolum video and another, RAV4 EV update. So I intend on doing weekly updates on the RAV4 EV project. What I'm going to do is I have enough projects right now that I want to keep everything separated so that I'll talk about the RAV4s on a weekly update, the Ranger EVs on a weekly update, and my solar projects on a weekly update, and maybe the kitties who are a little too loud for TV on another weekly update. But this way I can kind of keep everything separated into different topic groups and provide weekly updates on where I am on the project and what I've been able to accomplish in the last week. So I am going to be able to move forward a little bit with the Toyota RAV4 project. So unfortunately, I have some good news and some bad news, or at least some bad news and some unconfirmed news with the RAV4. And I also wanted to provide a little bit of a correction because in another video I had mentioned that these had a brushless DC motor. So that's not actually the case. I was basing that on some old information that had been published, I believe, in a Motor Trend review where they referred to it as an asynchronous DC motor. It's actually a permanent magnet AC motor. But my point about that still stands because Toyota, I believe, is actually the first automaker to use a permanent magnet AC motor in an EV configuration. I mean, it was another 20 years before Tesla was using permanent magnet AC motors in their vehicles. And just to give an idea of the efficiency increase, right, native to having that permanent magnet motor, the RAV4 EV with roughly the same capacity as the GM EV1 was getting about the same amount of range. So a completely different format, right? We're talking about a crossover SUV format versus a super sleek, efficient car, and it's getting roughly the same efficiency. And that would only happen, right, if the actual motor efficiency was significantly higher, which in this case it is. So that's just issuing that correction. There wouldn't be too much of a difference between a brushless DC and a permanent magnet AC motor, but there's a significant difference between a permanent magnet AC motor and an induction motor in terms of efficiency. Like the induction motors in the Ford Ranger electrics are significantly less efficient than the 50 kilowatt permanent magnet motor in this Toyota RAV4 EV. So in terms of one of the updates, bad news is I confirmed those parts that I thought looked like battery components that were all in the back of this white Toyota RAV4 EV. They were in fact from the battery case. So I checked, there's no battery inside the case of this RAV4 EV. So this is completely dead. In some ways that's good, in some ways that's bad, because what it means is I can just plan for a full battery replacement for this. What happens a lot with these older RAV4 EVs is that the batteries were pulled out and used to fix other RAV4 EV batteries, right? So they take out individual battery cells and check if they were good, and then they would use them to refresh other RAV4 EVs. So they were scavenging between vehicles. So what that does mean is I have a fresh battery case. You can't source new nickel metal hydride batteries. There's no way to repair them at this point. So just having an empty case completely opens up the option of converting this to a different battery chemistry, probably lithium ion or a LFP battery. So this one is dead in the water. And what I need to confirm is the silver RAV4 EV, does it still have its original nickel metal hydride battery? So even if it does have the original battery, does not mean that that battery is functional, but it is possible that that vehicle was stored with a functioning battery, that it was drivable at the time it was stored, But for those of you who remember the pickup and delivery of that RAV4 EV, the silver one, the battery was toast. There was acid everywhere. The entire battery cavity was just, wherever that battery was, the last battery that was in that vehicle was just completely, disintegrated, leaked, sulfuric acid, battery acid all over the inside of that compartment. So I got that all cleaned out. And I had the battery plugged in, and this was my mistake. It drained the battery. So there is very likely a short in that silver RAV4 EV, and it could be due to the DC to DC converter not working. It could be some sort of a parasitic loss, but it also doesn't tell me, though, whether the actual battery inside that vehicle is working or not, so, or if it's even present. So I want to confirm that, and if it is, I am going to initially try to recover it using the charger that came with the vehicle. So putting in that fresh 12-volt battery so it's functioning, and then hooking up the induction, the MagnaCharge charger to power so that they can then try to charge. And so the method that I'm going to use, I got a J1772 to 240 volt AC converter. And what this will allow me to do is plug in that paddle charger to either a J1772 at home, or if I end up taking it on a trip, this will also allow me to turn that stock induction MagnaCharger into basically a mobile adapter, if you will, a travel charger. So that is all what I'm going to be testing this week. And if it does work, I'm going to be using the lowest power J1772 I have in order to try to charge up that battery as it currently sits, because the thing with NIM cells is they do last a very long time, and they can be recovered with a very low input charge. So if I can get a very low input power charge going into that battery, it's possible that I can either rescue some cells or recover some cells, or possibly, just charge the vehicle to full, and then whatever that current capacity it has, I'll be able to drive it around and test it. So that's all going to be what I'm working on this week. It'll be nice because the car isn't licensed for road use, right? So, or insured. So it'll be nice if I can confirm whether the car actually works, and if I can just drive it even around the property, right? Just being able to move it so I can get it in or out of the way of different things, then that will be a huge help. What you guys doing? Oh no, bad boys. All right, so these are the MagnaCharge paddle chargers, and I don't know which one I don't want to say I'm going to be sacrificing one first, but this is the one that looks like it's been modified. And then, of course, this is the one that looks like it's been all original. All right, and I forgot to mention, I also got the VCI connector. And so this with the Toyota software should allow me to kind of figure out what's going on in terms of a diagnostic. My laptop is not exactly in great functioning form right now, so I might need to figure out how I'm going to do that. But I do have that option now. Let me see if I need to move this seat forward. Make sure I remember I have this. I don't know why the fuse is down. All right. I guess I missed a leaf. All right, so this is where the main disconnect is. And so on the other one, I looked, and this is how I was able to confirm visually that there is no battery in the other RAV4 EV. So you see here is the locking position, and then I guess it turns left, so counterclockwise. And this is there's a good seal there, so that's good. It sounds like rubber. Also, I think Toyota was just trolling people here. Service prug. No, it's the service plug. And then it looks like the disconnect is still there. So as far as I can tell, this battery is still in place. So before I get into doing anything under the hood, I would need to pull this disconnect and and make sure that the main voltage in the battery is taken off. But yeah, like I said, good rubber seal here. Just a very important safety aspect. So I just wanted to confirm that that was in place, because the one in the white RAV4 is not. And then this should just positively lock into place, I think. Yep, it's locked. So good seal. So this is the battery is here, and then this is good too, because like I said, my concern is, I got a NIM. I want to make sure that goes down there. I guess Toyota, it's not a truly flat floor. One of the Ranger EVs is a NIM, and it didn't come with the battery cells, which kind of sucks, because I don't know, maybe they're also a little bit valuable, but it would have been nice to have the cells to rely on too, because dimensionally it will also tell me what I can get away with. And then here, this is from Tucson EV. It's just a J1772 plug, but what it does is it provides this AC cable. So like I said, now I have to mate this to the MagnaCharge unit, and so that's 3 prongs to 4 prongs. We have the 2 hots, we have the neutral, and we have the main ground here, where the output from the level 2 AC, right, is 3-prong. So I'll have to double check on the paperwork on how to mate this up, and then of course with this, like I said, it's just a standard J1772, and in theory you could just hook this up to a different plug, right, like a socket, and then you could then from there plug in the units, because I was considering instead hooking these up with a standard NEMA 1450, just a quick 30 amp NEMA 1450 plug that would then let me plug this into the wall. And so in theory I can have one that's a wall unit and then one that's a mobile unit is I think the goal, but realistically also in terms of the reach, because of how short these cables are, if I did a wall unit, it would need to happen after these RAV4 EVs were actually mobile, because the distance between my NEMA plug to where I could mount one of these MagnaChargers to where it would be able to reach the RAV4 EV is just not a very long distance. Dale, you want to say something now? Dale, you going to say something now? Yeah, you are. Okay, that was good. That was good. Project your voice. So yeah, so the plan for this is hopefully they both work, and then one will be just a standard, mounted and plugged in by a, NEMA 1450, and then one of them will be a little bit more mobile, and I will still probably use this as a default charger here, but then this will give me the option of, you know, using just a standard EVSE to plug in, and then that will power the induction magnet chargers. Yeah, so just under the hood, I've left the battery completely disconnected. I got all of this cleaned out, all of the corrosion that was in there cleaned out. I'll need to double check. I might need to recharge this battery again. Hopefully it took the charge after the battery got drained, just because, like I said, there's some sort of short in here that's pulling power, and clearly the DC to DC converter that's in here is not recharging the 12-volt battery, and that could just be a result of the traction battery being drained. So and then of course we've got our charge inlet. So when I get the magnet charge ready and confirm that it's working, then I'm gonna replug in the 12-volt battery, get the systems up and running, and then see if I can actually get this charging. So still has the stock battery, and if it's drivable and chargeable, I'm gonna be super elated. So all right, just double checked to confirm that I wasn't going crazy. So with this, there is no neutral. This is only hot ground, and so what that means is this is going to end up with a orphaned neutral that I'm going to have to separate and just put off to the side. I don't remember if I have any wire nuts specifically, but I should have at least some electrical tape to cap off this end and then keep it separate from the rest of the strands. Tape off this neutral right now. Like I said, ideally I'll probably end up using a wire nut for it. Yeah, like I said, just enough to keep it from doing anything. This is also on the load side, so I don't know what would happen with this if it's just dead and unused. But I also don't know why this even has a neutral, given, as far as I know, these magnet chargers are not 120 volt capable, so I'm not sure exactly what that's about. It's probably not ideal, but you know, I'll leave that to the electricians to yell at me. And I also want to expose this, so I mean, I could use I probably want about an inch of this. I don't know if that's going to be seemed to do okay. This is a sheath around another sheath, so I really want to be careful not to do too much clipping here. And in fact, I'm going to get my better wire strippers for this. Got paper, cloth, lead. Dale, you're in the way. And one of the things about this, so here, Tucson EV, they have their explanations of it, but yeah, you have to make sure that this is off before connecting or disconnecting the J1772, because built into this is essentially signals letting it know that it can activate the power. So it's basically a spoof to let the EVSE know that it can start dispensing power, and then from there it handles all of the pilot and communication, and then just feeds the level 2 AC out from here. Okay. So I've got my 10 gauge. This is pretty soft insulation too. So I also have these self-sealing butt connectors that I'm trying out, so I'll see how well they work. I've used them on smaller applications. They seem like they do okay. In this, and I'm actually gonna cut off some of this excess copper. Maybe I needed that much exposed because this wire insulation here is seemingly thicker than what's on the MagnaCharge side of it. But yeah, I want to make sure that there's a water sealant here as well that I want to make sure is on the insulation as well as not just on the copper wire. And these connectors have solder in them, so they're supposed to ensure a very good contact between the two ends. Yeah, this would be much easier to do if this wasn't already attached to the Tucson EV box. My finger's getting tired, even though I know that pulling the trigger harder doesn't actually make it go hotter. Yeah, this solder didn't quite melt. Might be worth going through and crimping it down a little bit farther. But like I said, part of this is just the flexibility and doing this. I'll probably feel like I might want to do an additional heat shield or wrap over the top of this just in case. But I mean, these should all be, in theory, linked now. So I guess we can maybe do a test before sundown. Isn't that nice? I'm going to use the juice box first. It's not one that I want to hook up to the RAV4 EV because even at 16 amps, that's pushing more juice than I want to push. So maybe I'll wait for tomorrow to confirm that the 12-volt battery is connected and try it, but we're getting ahead of ourselves. Let's just see if this even works. Alright, so this is switched to the off position. Alright, juice box here. Okay. So I don't know if this light's not supposed to come on until I flip it, but let's go ahead and flip it on. Alright, so it's getting flipped on, and then unfortunately it does look like we're getting an error message. So maybe that's the test. I'm going to try the test button here. Okay, maybe a reset button. So all the lights came on, but also the error and the charge light came on. So Yeah, now it's a blinking error light. I wonder if that blinking error light means that it has to have a neutral bond. Because right now it's getting that power. All right, this is... So all the lights come on. All the lights go off. So I just turned it off. This would normally be safe now to disconnect. And it seems like there's maybe the capacitors were loaded. All right, so even with this in the off position, it still seems like there's residual power in here. This could just be the capacitor. See, just taking this out, putting it back in again. The error blinks. Now if I turn it on, error light comes on, and then the charge light comes on. Huh. So, yeah, I wonder if this can even operate without a neutral, which unfortunately makes this kind of, well, I don't want to say useless, but not useful for this purpose anyway. So, which is unfortunate, because this is what I was hoping I would have available to me if I wanted to be able to take this RAV4 EV on a trip, right? This is the only thing that really makes that usable. And then, of course, like I said, the other issue is if I do a NEMA 1450 connection, it's this one, it's just not going to be long enough. I mean, I could use it to charge the car, that's great, but like I would need even something like this to go to a NEMA 1450. So it's also, I guess, just possible that this specific unit is bad. There's already some fixing that was done on this one, so we'll have to see if either of these can be fixed or used. Oh well, bad news, but I gotta turn this off first, and then I can unplug. All right, one last attempt. I actually have the Bolt EV 120 volt that's running through 240s, but this is hooked up to the grid, not to the F3800. So still got that error light. But it's, no, it's not staying power. Actually, I don't remember this being that loose. Huh. It just looks like all the lights coming on, so I wonder if this is actually working. So maybe it requires a grid ground connection, because this is a true ground, not a neutral bonded ground. And this is actually the one that I would be willing to plug in to the RAV4 just because of the limited power. All right, let's see if we still have 12 volt power. I hope I don't have to rescue or replace this battery. All right, just do a quick power check. $12.67. That should be good enough. Let's see what happens. All right. I also grabbed the keys, so yeah, you can see the light is on. Go ahead and put this in there. Well, the headlights still work. So yeah, so battery is empty. All the lights are on. Okay. Well, let's go see. It's still lit up. Okay, and then here, does this have this side up? I mean, there's lots running in here, and this is no wonder the 12-volt battery died. But yeah, there's nothing here. There's no indicator. Yeah, I'm not seeing any indication of anything that's happening here. So nothing in terms of an interface that would let me know what's going on, right? I mean, there's a turtle mode, which I'm guessing means the battery is low or dead, but like I said, there's no indicator here of what's going on. So let me go ahead and close the hood and see if that does something. All right, so the hood is closed now, and I think that unlocks the charge port door. Oh yeah, so this opens. And then I don't know if there's any instructions again on how this would go in, but I think given the angle of it, that's the only way that makes sense. So I don't know if it... Okay, I heard a click. So I think the hood might have to be down. Yeah, I'm hearing clicking and contactors. I don't know if there's any inward indication. Okay, all right, well, unfortunately, it's an error. All right, well, I wanted to, well, back where we started again, I wanted to just do a little bit of this again while it was light, because we started running out of light last night and just didn't get a good visual of what was going on. This is the J1772 for the Chevrolet Bolt EV, but this is running to 40 volt right now. So it is hooked up to the grid. It's a lower power. And I almost wonder if I'm going to try this a few different times this week just to see if there's something that doesn't reset on its own. But yeah, just plugging this in here, switching it to the on position, it gets power. So this error light comes on, but so does the charge light. So I really don't know what that indicates because all of these lights are on. So I have no idea if that's just, okay, power's on and then it updates once the unit is plugged in. So that's something I'm going to have to investigate. Those of you who have experience with these units could probably maybe answer what that behavior is or what the expected behavior is when it's receiving power. All right, and then now, of course, with the 12-volt battery plugged back in, I have the keys, and so there is some power, but this is pretty much all of the error lights. I don't think the wheels are turned, so this is just the steering wheel being stuck in a not conducive position. But yeah, so all of the lights are on, and I think I knew this anyway, just from when I had picked it up and hooked up the 12-volt battery, things went on. But then, of course, what I found last night too is that with the hood up, it won't actually initiate a charge. So what I need to do then is go ahead and put the hood down and then open the charge port door. All right, so the key is off now. So I didn't check this. So what I'm gonna do is the hood is down now. So the key is off. I'm gonna go ahead and see if it should open. As long as there's 12-volt power, it should open even with the key in the off position. Yep. And I didn't try to start a charge with the key off. So let's see what happens there. So in theory, right, this is getting power. Power line's still hooked up. The charge port door open. This is all stuff that I was having a hard time getting filmed when it was still dark outside. So the cable just pulls right out and slides right in. And I'm hearing the same sort of contactors. I'm still hearing it there, but then over here what I'm seeing is an error on this side. Inside the vehicle, even with the key off, it's got an error message, and then it just goes a few times. All right, so with the dinging off, it doesn't really reset that charge controller messaging. Yeah, this is a very, very limited message in terms of what it's displaying or showing. So yeah, unfortunately, I don't know if there's a way to restore or refresh a battery like this without actually just pulling it out of the vehicle. And then of course that's a high voltage battery that's going to require lifting or at least positioning the vehicle and then pulling the case. There is a not recommended method that under the hood you can access the DC connections to the main battery, and people have used this in the past to install secondary chargers or solar chargers or whatnot to this vehicle. There was a version of this vehicle that came with a CHAdeMO, and I'm pretty sure that that's how it was hooked through those DC connector terminals. So there are some possibilities, and maybe it is just a matter also of cracking that open and just seeing what the traction battery pack voltage is, because it could be too low for the Magna charger to charge, and there are also possible methods of feeding DC current directly into the battery, and then once it gets to a high enough voltage, the Magna charge will then be able to charge it. So a few different possibilities, and I'll be investigating what the options are. All right, well, that was all I had for week 1 of the RAV4 EV project, or I'll call it episode 1 of the recovery project, and just catching everybody up to speed and what you can expect to look for on the next episode. So either I resolve some of these issues and then maybe we do a short drive video, or I go through the troubleshooting process to fix the things that weren't working. And then, of course, at that point, who knows what will happen. So, as always, thank you for watching.